Welcome everybody to my presentation, Unsupervised Insider Threat Detection System. And our war cry and motivation of our project is to detect next Edward Snowden as quickly as possible. So in 2013, Edward Snowden made huge ripples across the world of security professionals and researchers alike by leaking confidential NSA data, and which was of size of terabytes. This was an incident of an insider person leaking the organization's data. So insider threat is formally defined as a malicious act carried out by some insider within the organization. And studies suggest that the insider threats have been increasing over the years, even though many organizations have spent significant amount to safeguard themselves. But still, as the study shows that in past few years, it has increased by 47%. So this motivated us to attempt to solve this problem and try to catch next insider attack or next Edward Snowden within an organization. So the holy grail of our system is that we observe that when an employee becomes an insider attacker or an insider threat, he or she starts showing certain deviation in his or her behavioral pattern. For example, if employee is an insider threat, he or she might try to leak data by emailing outside the organization, and when he tries to do so, his normal behavioral frequency of emailing outside the organization may be changing. So observing such behavioral changes could help us to detect insider threats. So in addition to the individual's past behavioral pattern, we also model the behavioral pattern of the individual's community, and also we also model individuals or employees' peer behavioral pattern, and then we compare each individual's activity with its own behavior, past behavior, with the behavior of its community, and with the behavior of its peers. And if there is a deviation across any of these three versions of baselines, then we can suspect that the employee is doing something malicious and could be analyzed further by security analysts. All right. So now we describe high-level overview of our whole system, which we have designed. So our system first does feature extraction from the raw data. So the data set which we took to evaluate our algorithm or approach is the CERT insider threat data set, which contains data sources like emails, file copying behavior, PC access behavior, browsing behavior of an employee. So across all these data sources, we generate features. For example, for emails, we generate the frequency of emails sent outside the organization. For file copying activity, we extract a feature which tells us how many number of times per day a user copies files and how many files a user usually copies. So across all these data features, we generate three versions of normal baselines for each user, for each feature. And those are like user feature, the community's feature, and the peer feature. And we feed these three versions of each feature to our anomaly behavior detection module, which maintains which is actually a high-low pass rating algorithm based on rolling averages and standard deviation. And it ingests the generated features, and then compares the user's activity across all three baselines. And if across any of the baseline a user is found deviating, it flags the user's activity, the timestamp of the activity, along with beautiful visualization of the plots. So the challenges which we faced in this project were multiple, but few notable ones are that we had to handle the changing structure of the communities. Employees come into the organization, they leave the organization. So we have to update our community graph, and we did that monthly. And secondly, we also were facing the issue whether we should take group data, raw data, weekly, daily, or hour-wise. So it turned out that we found a sweet spot to reduce the number of false positives. That grouping the data daily is a right approach. And we also added the contextual information to reduce the number of false positives, which we were facing as a challenge. We solved that by including the psychometric score of an employee to filter out, weed out the low ranking flag threats. So now we present the two case studies which our system reported out of many. So the first case study is of user AJR0932. This user usually doesn't copy files to the USB sticks normally, but on September 9th and 12th, this user showed increase in the number of file copying activity. And this also was observed by our system across the community baseline. So the community's baseline behavior is this red line, but this yellow line shows the user's activity pattern, which is very much deviating from the normal behavior of the community. And similarly, it was deviating across the peer baseline. So we flagged this user as an anomaly, which was indeed a insider attacker as per the data set. And the second case study is of user BIH0745. And this user doesn't normally work post office hour, but after he resigned the office and was serving the notice period from 29 June to 15th July, this user started working late hours unusually. And it also shows that he also logged into different PCs at the same time. So this further was analyzed by our system, and our system also reported that this user is also malicious across for the file copying activity. So file copying activity of this user in comparison to its file copying activity of its community and its peer group is highly deviating. So our system truly flags that too. And one surprising observation which we saw is that this user is reported as an attacker on 5th of July in the data set, but our system flagged this user earlier than that, around 2nd of July, 29th of June. So our system seems to have the ability of actually predicting the attacker days before the actual attack takes place. And finally, our system also validated that this user is also anomalous across the login log-off pattern of the user. So his login log-off pattern was very much scattered than his or her normal pattern. So all these observations suggest that our system is very much effective in detecting these insider threats. And in conclusion, we have developed an end-to-end system that detects the insider threat, and our approach is based on an unsupervised anomaly detection algorithm. And the accuracy rate of our system is 90% with very much low false positives. We refer audience to our report for further and more detailed comparison with the state of the art. So, and as you have already mentioned, surprising thing is that our system seems to detect insider attacks days before they actually happen. And now we'll walk you through the code of we developed as part of this project. So the code is available online on GitHub link, which is there in the report. And following the README file and following the order of compiling, executing the files, we can generate the results, which would be inside the plots directory. So these would be the plots, and it reports all the users across all the features which were reported to be anomalous. So this user is reported to be anomalous on multiple dates, and so on and so forth. So thank you for seeing my presentation. I hope if you have any other questions, you can just contact me on Piazza. Thank you.